you who have joined us. If you haven't already, please make sure that you are muted, and please add your first and last name to the chat to record attendance for continuing education credits. We'll get started here in just a couple minutes.
How am I supposed to do that?
All right, I think we can go ahead and get started with our beginning introductory announcements. Welcome to all of you who have joined us. Sorry to sound like a broken record if you've heard this 5 times already, but please mute yourself if you've just joined us, and add your first and last name to the chat so we can record attendance for continuing education. Welcome, this is AIA Colorado's Committee on the Environment, second educational session of the year, Empowering Architecture with Passive House. We have a fantastic lineup of speakers that we're excited to shed some light on Passive House. And we're also going to take a second to give a plug for some of our upcoming sessions. We have our next one. I'm going to put a link to the Eventbrite in the chat. This is our session 3 in May 15th at noon. This will also be a virtual event. This will be focused on embodied carbon regulations, embodied carbon in LEED version 5, and the contractor's role and how they can track that. And then we have our 4th session, which will happen in June, June 19th at 12 p.m., also a virtual session. I'm going to put the Eventbrite link in the chat as well, if you want to sign up for that. This one is going to be focusing on materials beyond the surface, vetting materials for health, carbon, and impact. We're going to have Green Badger's founder and CEO, Tommy Lindstroth, as well as some of the COAT committee members presenting at that one. So hope you can join us for those as well. And we're going to go ahead and get started with our session 2. If you haven't already, please put your first and last name in the chat so we can record your attendance for continuing education. And I see there's one person. If you wouldn't mind muting yourself, we're getting a little bit of background noise. Everyone could just make sure that they're muted. Perfect. Thank you. Okay, so we have our learning objectives for today here up on the screen. I'll let you all read through those. I don't need to go through them verbatim. We have a really packed presentation, and we'd love to leave some time for Q&A later. So I'll go ahead and introduce the speakers for today and then pass it over to them. We have Tom Hoopman. He is a principal with Form and Flow. We have Lauren Shadid. She is a principal with Lauren Shadid Architecture and Interiors. We have Bunny Tucker, a senior architect with Shape Architecture Studio. And we have Jonathan Fertig, associate and senior architect at Davis Partnership Architects. And we're so excited because everyone presenting today is also members of our COAT committee. They've really stepped up to bring you a fantastic presentation today. So without further ado, I'm going to stop talking and I'm going to pass it over to them so we can get to the meat of the presentation.
All right, thanks, Maricel. So Tom Hoopman with Form and Flow. I'm going to kick things off today. I'm going to start with a high-level overview of Passive House to get everybody oriented. So as an architect, I think it's useful to think about Passive House as a way to really empower your architecture. And I think you'll see why as we spend an hour kind of walking through what Passive House is. Both the certification as well as the Passive House principles. I mean, they're a real game changer for creating high-performing buildings and design excellence. I find that using the Passive House principles flips the scripts within the design team. It actually allows and empowers the architect to own thermal comfort and the energy use of the building rather than, like outsourcing it to an engineer or consultant. It creates a better integrated design result. And by the empowering, we're taking design, but we're adding some building science to it. And we'll kind of talk about some of those techniques. And when doing so, I mean, this is far more effective at creating a sustainable, low carbon, low energy building than just what we can do with technology. In fact, I think most people understand that our average building out there is a very large mechanical system, and they're often large to compensate for designs that are not necessarily climate responsive or that don't have a great envelope, that have high heating and cooling loads. And I think this sort of creates a culture, a sustainable design approach that's common in our industry that really focuses on the technology, like the efficiencies of lighting and the heat pumps, as kind of our primary way of saving energy in the built environment. Now, that's important, but in doing so, we're missing a massive opportunity, right, to integrate design with some building science to fundamentally change the thermodynamic behavior of the building and the energy and carbon flows in those buildings. So that empowering of architecture, I think it's a way to add superpowers to your building. So here's some of the outcomes that you'll find when you do this. Obviously, ultra low energy buildings. Micro loads, what I mean by that is heating and cooling loads that are so much smaller than code kind of building loads. Therefore, they're thermally more comfortable, but also acoustically comfortable. They're healthy because there's a strong focus on air quality. They're more resilient with wildfire smoke, which we'll talk about, power outages, weather, extreme weather changes over time. Because we're investing in the architecture, it creates a higher quality kind of envelope, and that is more durable. And really, it's like putting lasting performance in the building. So it's the most cost-effective way to decarbonize the building. So I think to me, it's like the foundation that a really high-performing building is built on. It started with Passive House, really enables all the good things we want to do with our projects. And the good news is, all building types, all climates can be Passive House. And talk a little bit about the Passive House principles. I'm showing an expanded list here that was developed by the Passive House Accelerator. So if you're new to Passive House Accelerator is a nonprofit that is promoting Passive House. They've got just a lot of really good educational content. If you haven't checked them out, I recommend doing that. You'll get sucked into some great, kind of webinars and such, but they're awesome resources. Within this list, the top 5 here that I highlighted are really the core principles, kind of the original 5 Passive House principles, which is focusing on the envelope, right? So continuous insulation, high levels of insulation, removing and eliminating thermal bridges, integrating high-performing windows and doors, and creating a really airtight building, right? And then focusing on air quality, right, with a heat recovery ventilator as a core component of the mechanical system. But Passive House is also about passive strategies, right? So we want to orient the building well. We're thinking about the form factor. We want to have solar control. We want to have daylight. We want to be able to open the windows. All those good passive strategies are part of Passive House. So I'll talk just briefly about Passive House certification. And there are 2 options for projects in the US. So there's the original Passive House, which is from Germany, and it's administered through Passive House Institute, or it's often called PHI. And the US home for PHI is the Passive House Network. So that's probably the best place to start in getting familiar with the certification processes for PHI. And then there's a US, climate-specific US version of Passive House that's newer, that is administered and developed by the Passive House Institute of the US. So just a little bit more about the certifications. They come in different levels. The core, or the classic here, shown on the left, is like the original Passive House. And then they've expanded that to actually, like, if you've reduced energy beyond the classic and added more renewables. You could do plus premium, getting to net zero and positive energy results. And then the interfit on the bottom are basically the classic plus and premium for existing buildings. So a little bit different criteria for existing buildings. On FIAS, there's just two. So the core, which is kind of like the classic from PHI, and then zero, which is the integration of renewables for net zero or net positive result. And Revive is the name of FIAS's existing building certification that could also be core or zero. So these two certification, pathways, they're based on the same Passive House principles. They have used three primary targets, performance targets metrics. One of them is thermal energy demand. So this is different than just heating energy. This is actually, if you kind of add up all the heating or cooling loads of the year, it's the energy required basically to heat or cool the building before the HVAC efficiencies factored in. So that's actually a really good metric to measure how efficient the architecture is. So it's not counting on the efficiency of the equipment just yet. You might have heard the term TEDI, thermal energy demand intensity, that very prominent in Canada, but I'm hearing it also here in the States, is another way to quantify that metric. And then there's thermal energy demand. That's basically the total energy use of the building, pretty straightforward. And of course, air tightness with a blower door test, much stricter than code. So one of the great outcomes of doing a passive house is this dramatic reduction in both heating and cooling load and heating and cooling energy. So this graph kind of diagrammatically shows that. And what's a nice, really great benefit of that is it's a very good way to prepare your building for electrification, because one of the challenges is the peak heating loads in the winter become much greater, can often in a code building be much greater than the cooling load. And by kind of squashing them, getting them really small. In fact, they can be sometimes smaller than the cooling load. They don't factor into the electrical service size and create those kind of issues with the electrification process. And then, passive house is meant to be very cost effective. And in fact, it is cost competitive with code and conventional buildings. It's been proven. And we'll talk a little bit more about that shortly. The key way of doing this is one, the levels of insulation and the targets are cost optimized, and part of that is this idea of investing in the architectural envelope in order to reduce the loads, the heating and cooling loads, and therefore the mechanical system size and cost are reduced. So think of it as a cost transfer from your mechanical budget to the architectural budget, and keeping the budget balanced, but increasing the performance. So we've got that little hair dryer there by the mechanical passive house costs there. It's just a reminder of how small these loads can get. A small passive house home has a heating load that could be satisfied with, like the 1500 watts coming out of a hair dryer, for instance. So I'm going to pass it now to Lauren, and she's going to dive into passive house for residential.
Yeah, thanks, Tom. Hopefully everyone can hear me. Okay, can you all see my screen?
Looks great.
Okay, excellent. Hi, I'm Lauren Shadid. I'm the owner of and principal of Lauren Shadid Architecture and Interiors. I'm a certified passive house designer was certified through PHI. Tom mentioned the Passive House Accelerator, which I agree is such a great resource for learning from peers about Passive House, and people are always putting up questions and sharing resources. So definitely check that out. I'm going to talk today about Passive House for single family residential. Sorry, moved really quickly. The principles for passive house design are really the same for various building types, whether it's commercial or single family, but with single family, the scale's a little smaller, and which has some benefits and sometimes challenges, but there's also sometimes more of a kind of a positive emotional impact that passive house design can have on the owners and occupants of homes, since our homes are really meant to be our sanctuary. Some of the benefits that residential owners and occupants value most about passive house design include the superior indoor air quality for their family and loved ones, especially when people are sensitive, or have allergies. We've got homes that have really oxygen-rich air and lower CO2 values. The fact that the homes are so comfortable year-round and draft-free. Having passive house windows and superior insulation means a much quieter home, so you really insulate your family from external noise. It's one of the first things people sort of notice when they go into a passive house is just how quiet they seem. The air tightness and filtered fresh air is more conducive to a dust-free interior, which makes it easier on cleaning. This also has a benefit of keeping out bugs and other little crawly critters from the home. Homeowners love having lower operating costs and energy bills, along with just greater home durability. The energy efficiency makes passive house more resilient to power outages, as Tom mentioned. And of course, forefront on so many homeowners' minds right now is the increased fire resiliency. And there's several components of passive house design that are just inherently contribute to fire resistance. So now let's talk about form factor. Developing a simplified shape to the house early in the design process is really an important first step to helping you achieve passive house goals. As the diagram on the left depicts, the more surface area and corners that you have, kind of the more opportunity for heat loss. So when you have a simplified form factor, it just allows your home to be more efficient. And the same is really true for fire resilience. If you have a lot of undulations in the house massing, it just creates more opportunity for fire embers to lodge and ignite the home. So it's sort of like campfire logic, where it's harder to ignite like a big solid log than it is a bunch of small branches and kindling. And I just put up an example of a house that has a great simplified form factor from Shape Architecture. And this is the Sunflower House up in Boulder. Another early consideration in residential passive house design is orientation and glazing. And the orientation of the home is not always something we can maneuver based on the specific lot. However, it is often possible to utilize window placement to optimize opportunities for solar heat gain in the winter months and reduce heat gain and glare in the summer. Incorporating overhangs at the south-facing glass and using landscaping or other adjacent structures to shade the low sun angles at the east and west is helpful in controlling heat gain in the summer and optimizing in the winter. And I think somebody needs to mute. We're hearing some background noise thing. Okay. Passive house typically has at least triple glazed windows with appropriate solar heat gain coefficient. Using tempered glazing can also help with fire resilience. U-value requirements for passive house windows will vary based on climate zone and depending on whether you're following PHI or FIAS for certification. And it's just important to note that it's often surprising to people, but we typically lose most of the heat through the window frame. So it's actually better to have a few large windows than many small windows, as you can see in the diagram at the bottom. All right, let's get into the myths. People so often say to me like, oh, with passive house, you can't open the windows. It's so not true. I mean, yes, we want to meet air tightness goals, but if you've got favorable temperature, air quality, and humidity levels, the windows can and should be opened. Designing a home with continuous insulation from the foundation, walls, and roof is really critical to achieving the thermal comfort, reducing thermal bridging, and the possibility of dew point inside the walls, which can result in condensation and mold. So it's important to consider framing options to optimize continuous insulation and reduce that thermal bridging. So some of the examples that we often see in single family residential include the double stud wall you see in the top left and lower left, which can create a surface cavity. You can also incorporate a raised heel in your roof trusses, which eliminates that pinch point at the eaves, or using Larson trusses. And there's many great insulation materials out there that offer high performance along with low embodied carbon. Just a few, for example, mineral wool, straw sips, cellulose, wood fiber boards, prefab panels. All right, the purpose of the air barrier is to eliminate drafts and air leaks, and the importance of a smart vapor barrier is to improve the energy efficiency while allowing vapor to escape when needed, thus preventing moisture buildup inside the walls and minimizing the risk of molds. So it's important to educate subcontractors on site to ensure that the control of penetrations is maintained for proper sealing. So you'll often see, like in the lower right-hand image, on passive house construction sites, they'll put these signs up after the air control membrane is in place, just to remind subs about maintaining the integrity of the air barrier. You know, the proper air barrier just greatly improves the air quality of the home, significantly reduces the infiltration of smoke and pollution, and the vapor permeability contributes to the health and the resiliency of the home. An efficient continuous air handling system providing filtered fresh air with balanced heat recovery is often achieved in single family homes with an ERV or HRV, just depending on the climate. It should be placed ideally within the conditioned space and near an outside wall just to reduce losses. Keeping basements and attics inside the thermal envelope is typically the most efficient way to meet passive house goals for insulation, air tightness, and ventilation. In residential passive house design, the goal is to provide supply air to the bedrooms and living spaces and use areas such as the kitchen, bathrooms, and utility rooms for the extract air. So I just briefly want to touch on fire resilience. Passive house design prioritizes the air tightness and the systems of filtered fresh air. This keeps out smoke and also limits embers from entering the structure. Having that simplified form factor and minimal exterior vents or using spark arresters or something like a Vulcan vent can help keep embers from entering the structure. And additionally, high performance windows, especially if they're triple glazed, at least triple glazed and tempered, are also more resilient to fire entering the home. So I wanted to put up a link to some great resources that are out there. So this one is from the PHI database, and includes for both windows and also all kinds of other building components that they've already kind of pre-certified. And then FIAS has a similar link, and theirs is mainly for windows, doors, and panels. Okay, then finally, I just wanted to share this link to, this is a really inspiring short film that was featuring the construction of a single family passive house that was built in the Tetons, designed by Love Shack Architecture. It has great insights from the designers, along with EMU Passive and the University Corporation for Atmospheric Research and RMI. So definitely check that out if you have a chance. With that, I'm going to pass it over to Bunny.
Thanks, Lauren. I'm Bunny Tucker. I'm a senior architect at Shape Architecture Studio, and I'm also the current past chair of the Code Network. And we're going to move from Lauren's presentation on single-family residential and step up a scale and look at a small multifamily project in Denver. Sorry, not in Denver, just south of Denver in Inglewood. So the Inglewood Passive Duplex was the first certified multifamily project in Colorado. It's Passive House Classic, one of those levels that Tom mentioned. And it was a project that was designed and completed before my time at Shape, but a project that is special to me because it's the first Shape project that I visited. And this was also a deep collaboration between EMU, our Passive House modeler and consultant, and also Sterling Builders, who served not only as our contractor, but also as the client for this project because it was speculative. So why Passive House? Well, the site for this project is in a pretty undesirable location. It faces US Highway 285, which is a very busy, high traffic road. There's a lot of engine braking on this road, so it leaves the sites adjacent to this highway. It's very noisy environments. They're stinky due to all the air pollution, and the air quality in this area just isn't really great. And as Tom and Lauren mentioned, Passive House not only provides a lot of energy benefits, but also these additional benefits for improved acoustic comfort and air quality within a home environment. So the project is divided along the east-west axis, with one unit facing toward the south and the second unit facing toward the north. And north is right on this page, and that highway we just looked at is to the left on this page. The units are pretty similar in floor plan, mirrored across the party wall. They each have a detached garage that's not part of the Passive House envelope. And each unit is a 3-bedroom, 4.5 bath with an office on the ground level that also serves as that could also be a bedroom. So a big design factor in this project was figuring out how to get solar gain on the south, with one of the units getting the primary solar exposure along the south, and also that southern exposure being adjacent to this really terrible exterior condition. The way we did that was we designed, or we sort of right-sized the windows and located them in the center of unit 1 along that south edge, and put in a pretty tall window that would typically seem oversized for a Passive House project. The reason this worked is because it was centralized. It was at the stair location, and so that multi-height space allows for a lot of air mixing to prevent overheating. And the tree that you see beyond this window is also part of our energy model. It's providing shading in the summer, and when the leaves fall off in the winter, allowing additional light in the winter to reduce the heating demand. Also, there wasn't really a desire to have operable windows along the staircase as opposed to a bedroom. So it worked really well with the triple glazed fixed windows here to control any noise pollution from that nearby road. In addition to right-sizing the windows and getting the right heat gains, really dialing in the exterior envelope was critical to the Passive House design process. And you'll see it's not that much more robust than sort of a code wood frame construction wall. There's an additional 2 inches of insulation on the exterior. Originally, it was designed as mineral wool insulation, but this project was completed during COVID. There were material restrictions, so we switched it to EPS. It still worked. And a couple of other things to note about this. You can see it on the image in the right. The strapping is all wood to prevent thermal bridging from the wood siding attachment. And it's also oriented in a diagonal orientation to promote drainage from that rain screen. Beyond that mineral insulation, we have plywood as our sheathing, as opposed to an OSB, which is a lot leakier. And that plywood, which is pretty airtight, gets taped at the seams, and that provides our continuous exterior air barrier. The air barrier detailing gets a little bit trickier as we move to the party wall, and this was a big area of design development between us, EMU, and the builder, Sterling. The Intello that is stapled to the underside of the trusses between the structure and our ceiling cavity isn't rated for a fire-resistant party wall. And so we weren't able to continue that Intello across the party wall between the 2 units. Instead, we had to switch to a fluid applied air barrier that wrapped up over the cantilevered shaft wall that has to extend to the underside of the sheathing and then back over. It was a little bit trickier for constructability, but it's also part of the reason why both units are part of one continuous air barrier instead of separating them down the middle because of that firewall requirement. And it's a decision that you have to make with any multifamily Passive House project. Where are you going to draw that red dashed line? Are you going to divide the units? In a much bigger multifamily project, are you going to aggregate some of the units and separate them? And that then influences where your blower door test takes place if you have one or multiple. In this case, we just had one. And to summarize this project, I just want to emphasize that the performance values for the exterior envelope in some cases aren't that much more robust than the code requirements for this type of project. The R value for the walls is pretty similar. Also for the basement walls, we're looking at something that's pretty similar. And the roof value for the cathedral roof is at R67, which is just slightly higher than the R60 code minimum requirement. For the area of roof that's over the exterior deck, that R value was lower. And we were able to do that because we could submit this project with the PHPP in lieu of a prescriptive compliance path for showing conformance to the IECC. We do have a lot more significant insulation under slab and also much higher window performance and airtightness. And a really great resource in the bottom right of the screen are the databases for both PHI and FIAS projects, which will show you these values along with mechanical systems for certified projects. So you can find similar projects either in your climate zone or of a similar program type. And I should also add that part of the reason we're able to get performance values that are close to the code requirements is because we have 2 units in a single thermal envelope. If these were each standalone, detached, single-family houses, you would see those insulation values increase, as Lauren mentioned, and that's part of the sort of economy of scale we get with multifamily projects and why we're really seeing them be quite cost competitive. And I want to leave you with another tool that's been incredibly helpful in our firm. It's FIAS's feasibility report for a nature center we're working on in Denver. We did this study during our SD phase, and for $2,500, we were able to get all of the performance targets for the exterior envelope and our mechanical systems to meet the FIAS Core 2021 target. We're able to compile our SD package for pricing to meet the FIAS level certification and prove that a nature center for a nonprofit organization in Denver could be built for about $430 a square foot, which was an incredibly compelling argument for Passive House certification. And that link below shows the pricing and deliverables for the FIAS feasibility studies. And with that, I'm going to turn it over to Jonathan, who is going to take you through some much larger examples of commercial Passive House construction.
Cool. Thanks, Bunny. So I'm Jonathan Ferdig. I am an associate and senior architect at Davis Partnership Architects here in Denver. And like Bunny and Lauren, I am a certified passive house designer through PHI in Germany. And I'm going to give you a little bit of a higher level view and also a view of some larger projects. So to start out, I wanted to point out for folks who weren't aware, 2 years ago in 2023, the Passive House Network had its conference here in Denver. And if you had walked past Union Station, you may have seen 2 boxes sitting out front, one of which was constructed to typical code building, and then the other of which was used a Passive House panelized product. And so over the course of 2 weeks, 2,000 pounds of ice was left to melt in each of the boxes, and the numbers sort of speak for themselves. The code pod had 800 pounds of ice remaining, and the Passive House pod had 1,500 pounds of ice remaining. So the only differences were, generally insulation levels and window performance, but otherwise the orientation was the same, and the sizes of the boxes were the same. This had traveled, and initially the boxes were in Fort Collins for 2 weeks, then they were in Louisville for 2 weeks, and they finished in Denver in the lead up to the Passive House Networks conference, which was here. In addition, I serve on the Passive House Networks Policy Committee, so we work to expand adoption of Passive House nationwide, and I obviously have an interest in Denver in particular. So, stepping up in scale again from what the previous folks had shown you, this is a really beautiful project by Hermann Kaufmann in Austria. And, one of the things that I really love about this project is that not only is it Passive House, but it's also mass timber. So Passive House is addressing the operational carbon, and then the embodied carbon is addressed through the mass timber. And it's just, I think a really nice example that Passive House doesn't have to limit your creativity, that anything is possible. This is a really nice project by Perkins and Will up in Victoria, British Columbia, which actually hosted the Passive House Canada conference last year, which I was really fortunate to attend. They're doing a ton of large-scale commercial passive house up there, which, as I'll get into later in the presentation, is largely the result of codes that are in the province at large and in Vancouver in particular, although this project is Victoria, not Vancouver. It's enormous. There's 2 buildings, 782 beds across them, dining space, conference space, academic teaching space. The shared laundry, presents challenges with high air exchange rates. And this one as well has some mass timber. It's a hybrid structure. It was really fortunate to stay here for a couple of days in June and enjoy the really nice thermal comfort and excellent air quality. This is another sort of groundbreaking project, which is Sendero Verde by Handel Architects. It's the world's largest passive house residential project. This was just recently completed. And this hits on a theme that we're seeing a lot on the East Coast where projects like this are happening. They haven't really taken off here in Colorado yet. And that's the marrying of passive house with affordable housing. Again, this is a lot of this is code related in New York and the greater Boston area in particular. They're just the code is driving this type of construction. So this is a really beautiful project in Harlem. It also incorporates lots of community spaces. Again, stepping up even further in scale, this is an enormous project, which is multiple buildings across a 23-acre site with 1.4 million square feet of development. This is just outside of Boston in Newton, for anybody who's familiar with the area. It's known as the Northland Newton development. And so there's residential buildings, office buildings spread across this entire site. They vary in style, but in general, I believe the current plan is for them all to be passive house. Initially, it was a select few of them, and then the developer realized that, as Tom alluded to earlier, there really isn't that much of a cost premium, and the quality of the product that they deliver is just that much better. Again, Tom had mentioned the EnerFit standard. This is a really interesting project that just opened up not that long ago in New Haven, which is an EnerFit retrofit of Marcel Breuer project outside of New Haven. It was the Pirelli rubber headquarters for a number of years. This is also where we used to do a handoff when we'd go and visit my grandparents in New York when I was a kid. So it's really neat to see this one brought back to life. And it's just a beautiful building, and they did a really nice job renovating it. Another groundbreaking project that, again, just recently opened is the world's first certified passive house hospital. And this is not just a little medical center. It's 660 inpatient beds and 40 outpatient beds. This is in Frankfurt. And, hospitals pose all sorts of challenges that normal architecture, I guess you could call it, has to deal with, but in passive house in particular, the high air exchange rates and all of the internal loads from the equipment are a real challenge. And so this one was a pilot project with the Passive House Institute in Germany, which is something that you'll see across both Passive House Institute and FIAS, where if there's a new type of project that hasn't been done yet, project teams can work with the certifying agencies to figure out how do we solve these problems. So that was a similar thing that had happened at the Perkins and Will project up in Victoria, where they had this commercial kitchen and there hadn't been a commercial kitchen yet that had been certified passive house, and so they figured out how to get that to work. And then again, something that's, as this becomes so common on the East Coast in particular, projects that aren't looking to get on the cover of Architectural Record are also delivering passive house. And this is an affordable housing project in Brewster, Massachusetts, essentially around Cape Cod, that's delivering 23 units of very direly needed housing in this area. And there's tons of this sorts of stuff outside of Massachusetts, or in Massachusetts outside of Boston. Again, another first. This is the first passive house certified fire hall in North America. In the US, we call these fire stations. And again, this is Vancouver in general showing, leading the way. There's now a number of these across the area. And this project, as well, you can see they kind of threw the kitchen sink at it. In addition to typical passive house strategies of ultra airtight envelope and triple glazed windows, they had ground source heat pumps and a whole bunch of PV. And so, as more of these projects have come online, agencies have started to look at them. And so this is the Pennsylvania Housing Finance Agency, where they did a study of a few hundred projects, 268 projects that were both passive house and code, and found that essentially there was no cost premium. As project teams first set out to do projects, as there's a bit of a learning curve to getting this done, there would be a bit of a premium, 3 to 5%, and then that premium would tend to come down as both the design side and the construction side had more familiarity with this type of project. And so, as Tom had alluded to earlier, passive house doesn't necessarily, even though it is delivering a much higher quality building than a code compliant building, it doesn't have to cost a lot more. And in fact, it can be on parity. So as I've mentioned a number of times, Massachusetts is really the leader in America right now for passive house, and that's because of their specialized energy code. So all of these towns that you see in the darkest green, they've all adopted this specialized energy code. And so what that means is that any multifamily building that's larger than 12,000 square feet is being built to passive house standards there now. So they're building more large-scale commercial passive house than anywhere else in the country, and it's just really inspiring to see. Similarly, in New York, they have Local Law 97, which is driving a lot of large-scale passive house as well, similar like that Sendero Verde project that I showed. Locally, what we're seeing is the Denver Green Code makes reference to passive house, both PHI and FIAS, as compliance paths for the Denver Green Code. The state of Colorado has been developing a green code, and it pretty much mirrors Denver's path, that you can use a passive house approach as a compliance pathway for the energy chapters. Excel currently has a rebate for people pursuing their CPHT, which is the on the contractor side certification that you would get through EMU systems, which a number of folks have referenced, the local passive house certifier and trainer. And then these are in the bottom, there's British Columbia and Vancouver's approaches to mandating essentially passive house or some other options for their public buildings. And so again, that's what's a big part of what's driven the adoption there. In addition, that they've taken an approach that'll drive the market. So a lot of window manufacturers, ERV manufacturers are locating there, and we're importing them because we don't have them here. And quickly, the city of Denver has just recently announced that they'll pay the full certification and exam cost for either PHI or FIAS, which is $2,500. So you can do either the CPHD through PHI or the CPHC through FIAS. That's what you would take if you were an architect or an engineer. And if you were a tradesperson working for a contractor, you would do either the CPHT or CPHB through PHI or FIAS, respectively. The places where you do that training are Passive House Network for PHI, and FIAS has the training for their programs. And EMU offers it for the CPHT in particular. And then lastly, the city of Denver, in addition to announcing rebates for individual training, they've also mirrored a lot of which had originated in Massachusetts. Massachusetts also had been providing incentives for projects themselves. So now the city has a pilot program for affordable multifamily housing, $600,000 per project for the electrification side, and then another $650,000 that's split between pre-construction and post-construction, specifically for passive house. So you can get up to $1.25 million for a multifamily passive house building, and the city has $6 million available in this first round, and then hopefully we'll see it grow. And this is really when we're going to start to see this large-scale passive house take off. And so it's coming. And I guess I'll end there.
Thank you to all of our presenters today. There's so much information in there and also so many amazing resources. I was trying to put all of the links in the chat as we were going. So feel free, if you haven't been following the chat, open that up and feel free to copy all of those links in there. I'll also give a plug to the Colorado Green Building Guild. We have a scholarship. The next upcoming deadline is May 4th, but we offer a scholarship for a lot of high performance trainings as well, which all of these CPHT and DEC programs qualify for that. I know that we had a couple questions that were in the chat, so we'll go ahead and start with those, and then we'll just open it up to the rest of the group if you all have any questions. First one came from Scott Rodwin, and I saw, Tom, you put a link in there, so I'll start with the question and then pass it over to you. But how is OSB leakier than plywood, at the joints or actually through the wood?
Yeah, and I put that link on there because I mean I don't know if it's a combination. Remember it, and I didn't reread it, but I don't remember them saying specifically how. But it could be just maybe it's the nature of the way that the tape is sticking, or maybe it is through the actual material. I think that's a good question. But I thought the study would be interesting, where they actually compared side by side 3 different, kind of sheathing products and the air, tightness results. So dig into that link if you want to learn more.
Yeah, and Bunny, it looks like from the construction photo that you were using the zip system on the duplex. Is that right?
No, we just taped. My understanding is that the seams of the plywood were taped, which we do frequently. We don't put an additional zip over the plywood. If we use OSB, we'd have to use a zip system. And that's because it's in the article that Tom shared, I believe, but the plywood is just more airtight through the material, not at the joints, than an OSB for passive house level airtightness.
We have another question here from Sam. Can you help summarize the difference, benefits, pros, cons of certifying with PHI versus FIAS, maybe specifically to working in Denver, but also potentially projects throughout the US, both for single family residential and commercial project types and everything in between?
I think also just look at structural and see what structural is.
Yeah, Bunny, you might want to start with that because I know you've worked on both PHI and FIAS.
Yeah, so we have a take in our office on it, and it's whichever one's certifying fastest, just to keep the project going. And so when you work on a few projects at once, you sort of get a sense of the workload there. I think, sorry, within each certifying group. And right now we find that FIAS is a bit swifter. The other key distinction between the two systems is that PHI has a single set of standards for every building in the world, and FIAS has modifications per climate zone within North America. And so sometimes there are advantages locally for which one you end up going with for a certification system.
And do you have to have different trainings to sign up or to put your project through certification for either of them?
That's a good question. My take is that like you get the training through either one, it's the same building science, and there are a few different, numbers that you hit, but everything that you're learning through the training is the same. So I recommend that people just choose the training that works best for their schedule, based on when they're offering it. Make it easy, but for your certifier, which we don't do in-house, I believe that they have to be trained within the respective program. Is that right, Tom, Jonathan, Lauren?
Yeah, certainly on FIAS side, that's correct.
Yeah, I mean, I guess I might add a little bit to it that this question kind of opens a can of worms. The split between PHI and FIAS was not really amicable
Yes.
when it happened a number of years ago, and so there's a little bit of tension there. The thing that I find that I will just they're both going to deliver incredibly high performing buildings, and that goes without question. The thing that I appreciate about PHI is that, for instance, when I went to the Passive House Canada conference last year, I'm speaking the same language, even though I still would be speaking the same language if I was FIAS trained. The energy model is different. So when people are talking about the PHPP, which is the energy model which is used in PHI, that's different than the WFI passive model, which is used in FIAS. And so to that extent, if I was say FIAS trained, I wouldn't necessarily understand what they're talking about. It's in the end, it's all the same. But there is a larger PHI contingent in Colorado. Some states, I think, are a little bit more FIAS-y, and some states are a little bit more PHI. I think that the Rocky Mountain Passive House group that meets monthly, which I dropped the link in the chat, is organized through PHI, and so and the Passive House Network in particular. So I will just say that I think that's a difference locally.
Yeah, I believe FIAS was started out of Chicago. Is that right? So they have a pretty big cohort out that way, but I found PHI is pretty well established out here. All right. Oh, here we go. Another question from Joseph Vigil. Jonathan, any thoughts on differences between Passive House and IECC 2021 and the upcoming IECC 2024?
I'll say that I'm not super familiar with IECC 2024 yet, but I guess if you just took it from an EUI perspective, I mean, the Icebox Challenge, for instance, is a great example of that. That was built to, I believe it was to 2021, the code pod versus the Passive House pod. So, at a very small scale, that shows you that the energy use is still going to be much, much higher with the 2021 building. You're not going to have the thermal bridge mitigation. You're not going to have the improved indoor air quality, the improved thermal comfort, all of those other sort of co-benefits that are associated with Passive House. Just a typical code project isn't going to deliver that. And I would imagine it's going to be the same case with 2024, right? I mean, the ICC doesn't really move that fast. So.
And I don't know if registration is still open, but I know AIA Colorado has a code class tomorrow that dives into IACC 2024. Okay, any other questions from those who are on the call and haven't included their question in the chat? Just feel free to unmute and join the conversation.
So I'm curious with the group, if people want to put in the chat or just kind of speak up, if they're interested in learning more about Passive House and if that's something we should target as a code committee to bring in deeper. This is very high level. The training itself is much more intense, but is there an interest in learning more, doing case studies? Is that a good place for code to spend time on as far as resources? And if so, what anything specific?
I think just general everyday Passive House requirements that could be used on a regular basis, even if people don't want to go full Passive House, they could at least start moving in that direction. I think that would be a very helpful presentation.
So diving into the principles and the kind of the design, yeah.
Yeah, and I think that's one of the things about the Passive House training is that even if you're not working on a Passive House project, it makes you a better architect because you're looking at things that Passive House is trying to address. And so there's ways to address thermal bridging or, product selection on a code compliant building to still get better performance, even if it isn't pursuing Passive House.
Yeah, at the end of the day, it's building science, and understanding how a building works is going to make all of us better architects and do our jobs better. So being able to run anything from the energy modeling to detailing better buildings is advantageous.
I'd be interested in learning a little bit more about HERS. And I know that a HERS 0 is similar to Passive House, but we're seeing really strict HERS requirements in the Roaring Fork Valley, even for projects that are, you know, more than halfway through CDs having to suddenly comply. I'd be interested to see like thoughts on, you know, how you take a design that wasn't necessarily meant to be Passive House and what can you do?
Yeah, I think those passive house principles will lead to a better HERS rating. You know, I know there's a collaboration with FIAS, with the Department of Energy, and they've incorporated the Zero Energy Ready Home and Energy Star requirements, which has a HERS rating involved. So higher HERS ratings required, and part of that overall certification process. But that is like, you know, just part of the formal process with FIAS and a residential project. But there's a lot there that you could lean into to kind of address the HERS rating for sure, Jenny.
I believe even if we're designing as best as possible, I think that HERS 11 or 12 is almost the lowest that you can get before you get into renewables. And then from there, trying to offset it with renewable energy to get to net zero. We have some questions, an existing building focus, or maybe not a question, but a focus for a next conversation. An existing building focus might be great as a larger portion of our built environment can be impacted. Yeah, I think EnerFit could be a great focus for a presentation as well. How can we take some of our existing buildings, even historic ones, and bring them into compliance? Another question from Adam Wagner: how do you get the cost of Passive House training covered by Denver?
And I just dropped the link in the chat for that page on Caster's website. So that's for anybody who works or lives, or I think maybe even just does work in Denver. I think ideally you live or work here, but my guess is if you work in Boulder and live in Boulder but are doing work here, you could probably get the training covered as well. So on that link there, you'll find the details for it.
Great, thanks, Jonathan.
And for the CPHT training that EMU is doing, share that with your contractors, tradesmen that you work with. That's a fantastic training, and they just need to be living or working on projects within an Xcel Energy region to qualify for that 90% reimbursement. So they do need to pay for the training up front, and then they will be reimbursed by Xcel Energy afterwards. And they need to get the application in, I think, 3 weeks before the June training. So something to put on their radar ahead of time. And we have quite a few great links that were added into the chat. Any other questions that we have? I know we're coming up to the end, but we probably have time for a couple more. All right, well, I will once again give a plug for our next educational session. We have one coming up about embodied carbon, focusing on regulations, LEED v5, and the contractor's role. That's going to be May 15th at 12 p.m. And then following that, we have our final one of the year is June 19th. That is going to be focusing on materials beyond the surface, vetting materials for health and carbon and impact. We're going to have Green Badger's founder and CEO, Tommy Lindstroth, joining us, as well as other COAT committee members. So please join us for our next upcoming sessions. Thank you so much for joining us for this one. It's been a fantastic presentation from our presenters. Thank you. And to the engaging questions and conversations afterwards, and suggestions for what you all would love to continue learning. The COAT committee wants to bring education to AIA Colorado members for what you all want to learn. And we all find this fascinating because we all get together on a monthly basis to discuss high performance building. So any topics that you want to learn more about, send them our way. I can put my email in the chat as well. And we'd love to hear from you and bring more educational content. So thank you all for joining us.
Thanks, everyone.
Thanks.